Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0847 indicates a problem with the transmission fluid pressure switch B related to the third clutch in your Honda Odyssey from 2011 to 2017. This code suggests a short circuit or that the switch is stuck in the on position. The transmission fluid pressure switch plays a vital role in monitoring the pressure of the transmission fluid, which is crucial for the proper engagement of gears. Its location is typically within the transmission assembly, directly associated with the clutch mechanism. When this switch malfunctions, it affects the transmission's ability to shift correctly, leading to potential performance issues, such as being locked in specific gears. In this case, only third and sixth gears are available due to the fail-safe mode. It is important to address this issue promptly to prevent further damage and to restore the vehicle's functionality. DTC P0847 signifies a short circuit in the transmission fluid pressure switch B, third clutch circuit, or indicates that the switch is stuck in the on position. The transmission fluid pressure switch is an electrical component that detects the pressure of the fluid used for shifting functions within the automatic transmission. The information from this switch is used by the Powertrain Control Module, PCM, to ensure that the correct gears are engaged based on the vehicle's driving conditions. If this switch fails, it results in the vehicle being locked in certain gears, specifically only allowing shift to third or sixth gears due to the fail-safe mechanism. The placement of this switch is integral to the transmission assembly, usually located near the clutches, which means access may require removing certain components for inspection. This issue does not stem from mechanical transmission problems, but indicates an electrical circuit malfunction. The primary causes of DTC P0847 include possible electrical circuit problems, a faulty transmission fluid pressure switch B, and potential wiring issues within the transmission harness. Electrical circuit problems may arise from corrosion, loose connections, or damaged wires, leading to inaccurate readings or total failure of the switch to report pressure effectively. A faulty transmission switch indicates that the switch could be permanently closed due to internal failure, causing it to always indicate high pressure, which prevents normal operation. Wiring issues may involve shorts to ground or open circuits that disrupt communication between the switch and the PCM. Understanding these causes is crucial for effective troubleshooting, as addressing them helps in restoring the system's functionality and alleviating shifting issues. Common symptoms associated with DTC P0847 include limited gear shifting capabilities, the transmission being stuck in either third or sixth gear, and the potential illumination of warning lights on the dashboard. When the transmission fluid pressure switch signals incorrectly, the PCM will engage the fail-safe mode to protect the vehicle's transmission, which may result in experiencing reduced performance while driving. Additionally, you may notice that shifting becomes sluggish or unresponsive, making it difficult to achieve intended acceleration or deceleration. These symptoms should not be ignored, as they indicate underlying issues that can worsen if left unaddressed, potentially leading to more significant mechanical failure or costly repairs. The first step in troubleshooting DTC P0847 involves turning the ignition switch to the on position, designated as 2 in Honda terminology. This activation of the vehicle's electrical system allows the use of the Honda Diagnostic System, HDS, to access the information necessary for diagnosing the issue. After turning the ignition on, you need to clear the DTC using the HDS, which resets the onboard diagnostics and prepares the system for a fresh assessment. Following this, You will check the third pressure switch signal listed in the automatic transmission AT data. The aim is to determine whether the pressure switch is signaling on or off. If the switch indicates on, it verifies an issue. If it's off, it may point to an intermittent failure, suggesting that there could be no active problem at this moment. Upon determining the status of the third pressure switch, if the reading is on, you will then proceed to the next testing phase. This confirms that the transmission fluid pressure switch is indeed reporting a problem, warranting further investigation. However, if the switch signal is off, it could suggest that the issue is intermittent, meaning that the circuit may be functioning appropriately at that time. Such intermittent failures may not always generate a code or leave other indicators. Therefore, careful monitoring is essential. Moving forward with the diagnosis when the signal is on can lead you to pinpointing whether the issue is with the switch itself, the wiring connected to it, or further up the circuit involving the PCM. For this step, you will turn the ignition switch back to the lock position, which is 0, before disconnecting the transmission fluid pressure switch B, the third clutch connector. This disconnection eliminates any potential interference from the switch while you continue testing. After disconnecting the switch, turn the ignition switch back to the on position, 2, and once again check the third pressure switch signal using the HDS. At this point, you want to confirm whether the switch now reads off, indicating that the problem could indeed lie with the pressure switch itself, and not with the wiring leading to it. If the reading is off, the recommendation will be to proceed with replacing the problematic switch, restoring optimal function to the transmission system. Should the readings from the third pressure switch still indicate on in the previous step, you will now turn the ignition switch again to the lock position, 0, and jump the short circuit anytime SCS line with the HDS tool. This action isolates the HDS from other circuits, allowing for more precise testing of the components being investigated. Next, disconnect the PCM connector C, which is crucial for the proper diagnostics because it houses terminals integral to the transmission operation. This step is vital as it allows you to evaluate potential communication errors or faults stemming from the PCM. Ensuring proper isolation and connection integrity will help to confirm whether the issue truly lies with the switch or within the PCM wiring and circuitry. The final step involves checking for continuity between the PCM connector terminal C38, which is a vital point in the transmission control process, and body ground. You will perform this test to ensure that there is no unintended electrical pathway, creating a short to ground in the wiring between terminal C38 and the transmission fluid pressure switch, B connector terminal. If continuity is present, it indicates that there is indeed a short circuit in the wiring, requiring repair. If there is no continuity, this points towards the possibility of needing to replace the PCM itself, as it may not be performing effectively. These final checks are pivotal, elaborating on whether the root of the issue is within the wiring harness or the PCM, ultimately guiding the technician toward the appropriate repair actions. After completing all troubleshooting and repairs related to the DTC P0847, it is essential to conduct final verification of your work. This involves performing checks on the entire system to ensure that the transmission is shifting correctly and that no further DTCs are present. Using HDS to clear any stored codes once more will confirm that your repairs have resolved the issue. After confirming a lack of active codes or errors, perform a test drive to evaluate the transmission's behavior in various driving conditions. Properly functioning transmission fluid pressure switches should provide stable signals and allow for optimal gear shifts without engagement problems. This comprehensive approach ensures the issue is adequately addressed, and reaffirms the reliability of the repairs made. As part of preventive maintenance to mitigate DTC P0847 from reoccurring, regularly inspect the wiring associated with the transmission fluid pressure switch and related circuits. Look for signs of wear, corrosion, or damage that might lead to shorts or interrupted signals. It is also essential to check your transmission fluid levels routinely. Low fluid can affect the switch's operation and overall transmission performance, leading to further complications. Ensure that your diagnostic tools, like the Honda Diagnostic System, HDS, are calibrated and functioning correctly for accurate assessments and repairs. Regularly updating software in the PCM, if applicable, can also help maintain operational integrity. Adhering to these maintenance practices helps to keep the vehicle running smoothly and reduces the likelihood of future transmission-related issues. In conclusion, DTC P0847 reveals significant issues related to the transmission fluid pressure switch B, emphasizing the importance of both electrical integrity and systematic troubleshooting. Understanding that this problem stems from electrical faults, not mechanical issues, clarifies how to approach repairs. Detailed troubleshooting steps guide you through verifying the issue, ensuring accurate readings, and ultimately diagnosing whether to replace the switch or address wiring or PCM concerns. Employing thorough checks and preventative measures can prevent future complications from arising. By maintaining vigilance and adhering to problem-solving protocols, you help ensure your Honda Odyssey continues to perform optimally for years to come. Please like and subscribe to the channel. See you next time.